Okay, this is a worked paper. It's a foundation paper, paper 1 from 2017. And so this is an AQA paper. So I'm not doing all the questions, just going through a selection of questions just to develop those particular topics, give you a bit of more insight. And also in terms of the presentational side of it, you know, the sort of things that you kind of want to be writing with your solution in order to help the examiner. Right, so let's just go down, find the first one we're going to look at. Okay, number 5, here we go, work out 58 times 73. Right, well, we could do long multiplication for this, and you may have done long multiplication. It's a bit of a cumbersome process, really, is long multiplication. So very often for things like this, we can use alternative methods. Sort of tend to be referred to as chunking. And in this case, if what we do is we write our 58 as this, 60 minus 2, and our 73 as 70 plus 3, like this, in brackets, then this looks like an algebraic expression that we might want to expand, where every term is multiplied by every term on the left multiplies the terms on the right, and vice versa, obviously. So if we draw in our little face here with the eyebrows over the top, the mouth underneath, and the chin there, and these give us the pairs, just as a bit of a check as to what we're multiplying together. So let's just go through each of these in turn. So if we multiply the this eyebrow anyway, 60 times 70, well, that's easy because we know 6 times 7, and there's just a couple of noughts to go on the end, 4,200. The other eyebrow is minus 2 times plus 3, that's minus 6. The mouth is minus 140, and then the chin is on 180. So if we simplify that to 40 and then simplify this to 34, we can see that we end up with 4,200 plus 34, which is 4,234. So that method might appeal to you. You know, you can extend it if these numbers are 3 digits, just gets a little bit more cumbersome there, but works quite nicely if we just got a 2-digit number times a 2-digit number. Right, let's move on. 500 people are asked if they drink coffee. 9/10 say yes, and 20% of the people who say yes drink at least 3 cups a day. So this is a little bit of a test in the first place on fractions and percentages. So I've just done the working here. So the ones who say yes, we've got 500 times 9/10. Could have written this the other way around, 9/10 of being multiplied, 500, and that's 450. And then we're going to take our 450 and take 20% of it, and just 20%. And this is, if you want to write a percentage as a decimal, this is one way of doing it. 20, the denominator line here means per, and cent is 100, so divide by that. So really, it's just what you, as you say it, isn't it? 20 divided by 100. And that works out to be 90. And then it goes on, says complete the frequency tree. So we can take those numbers there, we put our 450 in here, and with these frequency trees, these two here that come from this rugby ball or whatever here, these two are going to add up to this, just as these two add up to this. So that's how we would complete the frequency tree. And then the last part of the question says, what fraction of the 500 people drink at least 3 cups of coffee a day? So we can just take this 90 and as a fraction of the 500. So and that 90 500s, which of course cancel by, so out the by 2, divide through by 2, we get 9/50ths. We could actually just, regardless of the number of people we start with, the fraction is actually the same, you know, according to these rules here. so it'd be 5,000 or any other number, we would have the same overall fraction, and that's going to be given to us by the product of those 9/10 times 20%, which works out to 9/50. So that's just two different ways of looking at it. Right, by rounding each number to the nearest 10, estimate the answer to this thing here, 61 times 47 over 102. So we've done this, I think, probably before. If we usually we kind of round things to one significant figure, don't we? And that's what more or less what we're being asked to do here, in a sense, because this is going to round to 60, this is going to round to 50, this is going to round to 100 if it's to the nearest 10, which is still to one significant figure. So so we get this. This is what it's approximately equal to, and then there's a bit of cancellation here because these zeros will go out, and we just end up with 6 times 5, which is 30. So that is that one. Nadia has £5 to buy pencils and rulers. She says, I will buy 15 pencils, then I will buy as many rulers as possible, and with my change I will buy more pencils. So how many pencils and rulers will she buy? So we can just work through this one statement at a time, really. 15 pencils at 8p each is going to be £1.20, and that's going to leave her with £3.80 in her pocket, from which she's going to buy rulers at 30p. How many? Well, it's going to be £3.80 divided by 30p, which is 12, and then with a remainder of 20p. And those 20p will buy her 2 more pencils. So those 2 can go with a 15, and that's 17 pencils, and then the 12 rulers. There we go. Okay, carry on a little bit. So it says work out 3/8 times 11, or 3/8 of 11, we might say. Now 11, of course, it's a whole number, but we can think of a whole number as a fraction, because in a sense it's 11 once, 11 over 1. And as such, sometimes useful to think of this 11. The 11 really is on the numerator line. Whole numbers are on the numerator line. When you're doing any such calculation as this sort of thing, we're multiplying out a fraction. So our 3/8 times 11, we're going to multiply across, and as I say, the 11 is upstairs. So 3 times 11, 33, and 8 times effectively 1 at the bottom is 8. Okay, now this is an improper fraction, and because the 33 is bigger than the 8, so we need to do something about that if we're going to get it as a mixed number. And if we could split this 33 up into 32 and 1, and we can actually then write it as 32/8 and 1/8. Why 32? Well, because we know that 32 is divisible by 8 4 times, in fact. So this expression is actually 4 and 1/8. This is the 4. This is the 8, and when we write it as a mixed number, we don't put the plus in, we just write it like that. 4 and 1/8. Right, okay, so that's number 10. Let's just scroll down to this one. A football team has P points. A little formula here. P equals 3W plus D, where W is the number of wins and D is the number of draws. Well, we've seen this before. I think anybody who's looked at league tables, and particularly football Premier League table, you know, this is how we calculate the number of points. So in 12A, a team has 6 wins and 2 draws. So W is 6 and D is 2. So really what we're doing is we're just substituting into our equation. So we're putting 6 in for W, and of course this is multiplied. 3W means 3 times W, doesn't it? So 3 times 6 plus 2, that's D, and that is 18 plus 2, which is 20 points. So that's what we've got there. Now in this one, there's slightly more to it. After 33 games, a different team has 53 points. 11 games were drawn. how many were lost. Well, in order to work out, I mean, our formula doesn't really have anything to do with lost games, but we would know that if we know the number won and the number drawn, then we'll be able to work that out. We know the number played as well. So what we're going to do is we're just going to do some substitution. Let's put these numbers into our equation. So we haven't got anywhere to put this 33, okay. But we've got the 53, and that's going to go in for the number played. 11 were draws, so we've got 11 there. So we've got 53 equals W times 3, 3W, plus 11. And that's going to give us, if we subtract 11 from each side, it's going to give us this. And then divide through by 3 is going to give us, W is 14 wins. Okay, well, we know what we need to know now, because if we subtract our wins and our draws from our number of games, it's going to give us 8. So that will be the number of losses, number of defeats. So that is that one. So a little bit of algebra. And I think the key thing is, yeah, we've done our substitution here, and it's left us with an equation to solve. So fairly common kind of problem. Right, let's scroll down and have a look at this one. A number is picked at random from the first 4 prime numbers, and another number is picked at random from the first 4 square numbers. And then the 2 numbers are added to get a score. Let's complete the table. So this is a sort of addition table. Now we've had to complete this one here, the 4th square number, which is 4 square, 16, and the 3rd prime number, which is 5. So I've had to do that. And it's filled out one entry for us, 12, just to, I think, illustrate that 9 plus 3, where these 2, the column in this row, coincide, then it's 12. So we just have to carry on and complete the rest of the table. So these are all the sums, so 7 is 3 plus 4 and so on. So having done all that, we've got 16 different possibilities. Now 11 occurs twice, but we're still counting it twice because it's we can achieve it in different ways. So the point is that if we choose any one of these numbers at random, then well, we've got 7 prime numbers here in this table. So the probability that the score is going to be a prime number will be 7 out of 16, 7/16. It's the probability. Okay. We could ask ourselves other questions like, what's the probability it's an odd number? We would have to add up the number of odd numbers, and it would be whatever that is over 16, and so on. Right. There's a ratios question. So in a school show, the ratio of girls to boys is 1 to 1. That means for every boy there is a girl. Okay, so the number is going to be the same. Girls who sing to girls who do not sing is 1 to 2. Now 8 girls sing in the show. How many students are in the show altogether? Okay, so if there's 8 girls that sing, then because this is 1 to 2, then there must be 16 who don't sing. So for every 1 girl, there's 2 girls that don't sing. Everyone who sings, there's 2 that don't sing. So the total number of girls is 24, and we know that the number of boys to the number of girls is a ratio of 1 to 1, so the same number. So that's 24. So there's 24 girls, 24 boys, 48 in the show altogether. That's 48. All right. Now then, it's getting more interesting. P and Q are points on the line 3x plus 2y equals 6. Now, this is an equation of a line, a straight line, in fact. And as the equation of the straight line, what it means is if we take any point in our xy plane here, then if if we take its coordinates, actually it's x coordinates and its y coordinates, and substitute the x value in there and the y value in there, then if the point is on the line, then it will, the result of the left-hand side will be 6. If the point is not on the line, then we'll put the x and the y in there, and the answer won't be 6, something else. So so this is a complete definition of all the points that sit on this line, whether or not they're whole numbers or fractions or decimals or whatever. Okay, so now the follow-up to that is that if we know one of these, then we can plug it into either the x or the y, and then we can use that to calculate the other one. So in this case, this point P has got an x coordinate of 0. We don't yet know what the y is. So if we put x equals 0 into our equation, we've got 3 times 0 plus 2 times y. 3 times 0 plus 2 times y is 6. And that's going to give us y equals 3. So that means the point P has got a y coordinate of 3. We already know the x one. So it's the coordinates of P are 0 and 3. And then likewise with Q, we know the y, we've got to work out the x. So a y of 0 is going to give us this. If we substitute y equals 0 in here, we're going to get 3x plus 2 times 0 for the y equals 6, x equals 2. So that means that Q is the point 2, 0. Right, so, and it goes on to say, draw the line 3x plus 2y equals 6, 4 values of x from -3 to 3. So we can, so we know our 2 points here, P and Q. So this is P, 0 along and 3 up, and Q is 2 along and 0 up. So plop those points in, and then we know it's a straight line. So if we just draw the line through those points, making sure that we cover all this, all these values of x from -3 to +3. I've done a little bit more, in fact. Then this is the line. And if we take any other point on the line, incidentally, this here, it looks like -2, 6, x equals -2, y equals 6. And we pop those values into here, then we will find that the result of the left-hand side is 6. Just by way of a check. Okay, all right, we're going to move on now to number 17. Circle the expression that does not simplify to y cubed. So y times y times y. Well, these are all y to the power of 1, effectively, aren't they? We don't write the 1 normally, but it is there, y to the power of 1. And if we are multiplying numbers with the same base, the base being y here, then we add the indices. So it's the power is 1 plus 1 plus 1, 3. Here we're dividing, so we're going to subtract the powers, 4, and then is minus, this is y to the power of 1, so it's 4 minus 1, which is y to the power of 3, y cubed. This one is y to the power of 2 plus 1, because that's a multiplication. So that is y cubed as well. This one is y to the power of 6 minus 2. Y to the power of 6 divided by y squared is that. That's y to the power of 4. So that's the odd man out, basically. Okay, so we circle that, get our mark for it. Write the number 6,005,200 in standard form. Well, you need to just go through this when you sort of see a sort of narrative form of a number, and just pick out the the numbers and write them out here like this: 6,005,200. But then it says in standard form. Now, in standard form means we want to write it in the form. So the first part is going to be between 1 and, well, I suppose 9.9 recurring, really. That's the range that we're looking for. So that's fine. 6.0052 times 10 to the power of 6. And then we kind of need to just check that, really, because what the 10 to the power of 6 means is we're going to move our decimal point 6 to the right. So if we start off with 6.00552, then if we move 6 to the right, go on 2, 3, 4, 5, 6, then that basically is going to be right, isn't it? So that is your number in standard form. Okay. Right, and carry on. Use 8 kilometers per hour equals 5 miles per hour to convert 96 kilometers per hour to miles per hour. Well, we could probably do this better once we've done part B, actually, but I think probably intuitively, you know, if we know that a kilometer is less than a mile, then we would expect 96 to be in miles per hour to be a lower number, wouldn't we? And what's going to be? Well, just I think in, you know, a bit of common sense, it's just 5/8, isn't it? You know, we multiply by 8/5, then obviously that's going to give us a bigger number than 96 that we don't want. So 5/8. So if we multiply 96 by 5/8, that's going to give 60 miles an hour, and that passes the sense check. Then you know, we can take that, I think, as read, 60 miles an hour. Now the next part is a little bit more tricky. X kilometers per hour equals Y miles per hour. Now we're going to use this 8 kilometers per hour equals 5 miles per hour to write a formula for Y in terms of X. All right, so what I've done here is I've taken this first statement and I've written it like this. Okay, we've done a bit of cross multiplication. You know, we've divided through by Y, divided through by kilometers per hour. So, all right, so we're, you know, that's more or less the first statement. And then the second one here, well, I've done something similar. I've divided through by 5 and divided through by kilometers per hour and got this statement. Now, this equals this. So therefore, this equals this. And that's what we've got here. X over Y equals 8/5. And if we just rearrange that so Y is the subject of the equation, then that's going to give us Y equals 5x/8. Okay, and I think if we knew that from the start, then we could have plugged in our part A question. But anyway, that's what we're doing there. All right, here is a circle touching a square, question 20, and the area of the square is 64 square centimeters. Work out the area of the circle in terms of pi. So that means that we're going to see a pi in the actual thing that we're submitting as an answer. So if the area of the square is 64, then that should tell you that the length of each side is 8, because 8 squared equals 64. And I think we can probably see, therefore, that the radius of the circle is going to be 4. It's just half of that, isn't it? Because it's all symmetrical. So that's fine. So the area of a circle is pi r squared. We know what r is. It's 4. So 4 pi times 4 squared is going to be 16 pi. And that's our answer, 16 pi square centimeters. Now these questions, incidentally, they you know, you've got a little bit of a template there. Leaves the units in for you, but if it doesn't put the units in, you always need to make sure that you're putting the units in, into your answer. Okay. Billy wants to buy these tickets for a show. 4 adult tickets at £15 each, 2 child tickets at £10 each. A 10% booking fee goes on, and then 3% is added for paying by credit card. Right, work out the total charge. So 4 times 15 plus 2 times 10 is what we're looking at, isn't it? We've got 4 lots of 15 and 2 lots of 10. That's £80. And if we add 10%, well, 10% off 80 is pretty straightforward, that, isn't it? So that's £8. So that's 88. And then we've got to add 3%. Now, how are we going to do this? Right, well, I've just basically I've looked at this and gone, well, if we're adding 3%, then what we're doing is our multiplier is going from 100% to 103%. So our multiplier is 1.03 or 103 over 100 if we like. So so then we would have to work this out. And so 3% of this is going to be £2.64. You probably just need to multiply that out yourself, and that's going to give you an answer of £90.64. Okay. Now this one is getting interesting, but this is a little bit like the previous question, where we're sort of using units, and quantities, using a bit of algebra, basically. So let's have a look at this. Density equals mass over volume. Okay, well, you probably know that if you're doing any physics. Now, the mass of solid A is 6 times mass of solid B, and the volume of a solid is 3 times the volume of solid B. And I think I might have got my A's and my B's mixed up here. So let's just put this right in flight. So if density is mass times volume, then the density of B is M over V. So the density of A is 6 times that mass and 3 times that volume. Okay, so 6 divided by 3 is 2, so it's basically equals to 2 times mass over volume. Now, mass over volume is the density of B. Yeah. So the density of A is 2 times the density of B. Okay. So that's the idea with that. Okay. So I think it just illustrates the fact that if we can work with letters instead of numbers, and we don't know the numbers, let's just put letters in there, and you may well find it works through, as it does with this one. And then we go on to a similar thing. Average speed equals distance over time. If the distance is halved and the time is doubled, what happens to the average speed? Okay, well, I put average speed with a little prime here, a little mark. So that means, the sort of revised thing, having halved and doubled and done that stuff. So that's going to be half the distance divided by twice the time. Okay, so now that's a quarter times the distance over time. Why is that? Let's just think about multiplying fractions or dividing fractions. So we've got half divided by 2, and as I mentioned before, 2 in a sense is a fraction, isn't it? 2 over 1. So so if we divide by a fraction, we multiply by the flip of that fraction. Remember that rule. So we've got a half times the flip of this, which is a half, and that's going to be equal to a quarter. So we've got the kind of revised average speed is equal to a quarter of the original average speed. So that's what we got there. So that's divided by 4. Right. Now, a regular polygon has an exterior angle of 20 degrees. Work out the number of sides of the polygon. So the thing we need to know here is when we've got a polygon, then the total of the exterior angles is 360. And if we can, if this is a rectangle, it's not actually a regular polygon. But it illustrates this point about 360. So if we add up these angles, well, they're all 90 in this case, aren't they? They add up to 360. But if we had something with 5 sides, then it would still add up to 360. Why is that? I don't know. Imagine you're driving a car along here. and then you turn through 90 degrees, you turn again through 90 degrees, you turn again through 90 degrees, and you turn again through 90 degrees. So you've gone through a total of 360, and that will be true regardless of how many sides the polygon has got. But here we know that the exterior angle is 20 degrees. So so how many 20s can we get into 360? Well, we're going to get 18. So the polygon must have 18 sides. Incidentally, if we know that the exterior angle is 20, then that also tells us, because you know, the exterior angle and the interior angle, 90 and 90 in this situation, but regardless of the polygon, they're going to add up to 180 angles on a straight line. So therefore we know that the interior angle of an 18-sided regular polygon is going to be 180 minus 20 is 160 degrees. So that's not actually in this question, but that might come in handy in another question. Right, so we'll go down to this one. Right, 36 as a product of prime factors, and give your answer in index form. Now, you might have seen this done with trees and things like that. It seems a bit overcomplicated to me. Much easier, I think, to write it out with a series of equals like this. And we start with the lowest prime, which is 2, and say, will 2 divide into 36? Yes, it will. And that's going to give us 2 times 18. Then we look at this N1 and say, will 2 divide into that? Yes, it will. 2 times, this becomes 2 times 9, which is 18. And then we look at the 9 and say, will 2 divide into that? No, it won't. Will 3 divide into it? Yes, it will. And 9 is, in fact, 3 times 3. Now, some got prime number here, so we've finished that process, and we can see that we've got 2 2s and 3 3s in this product, so it's 2 squared times 3 squared. So that is 36 expressed as product of prime factors in index form. All right, so now then on to number 28. This is the last one we're looking at. Solve the simultaneous equations. 2x plus y equals 18, x minus y equals 6. Okay, so simultaneous equations. Now, each of these equations has got 2 unknowns, so we couldn't solve that on its own, and we couldn't solve that on its own. But what we're actually looking for are the values of x and y, which satisfy both of these equations. Okay, so and that's what we mean by solving them simultaneously. Now, in this case, this is pretty straightforward. We can, because I've written them out again here. Now we can add the equations. I mean, if we think of some 2 sets of scales, and they're in balance, we would take the left hand of each scale, put them on another scale, take the right hand things and put them on a scale there, and it would still be in balance. So that's essentially what we're doing when we add or subtract equations. And in this case, we've got a y and a minus y, so that yields nothing. So we've got 3x equals 24, x equals 8. That's fine. So we've got the x value, but what we need to do is to find the y value as well. So we can take either of these equations. You might want to take both just to check, but if we take this first, we usually take the simplest one. X minus y equals 6. We can put our x value in there. That's 8. 8 minus y equals 6. And then just rearrange it. We need to add y to each side, subtract 6 from each side. We're going to get that, giving y equals 2. So we've got x equals 8, y equals 2. Those are the 2 values which will satisfy both of these equations. Now, we could check that. If we put x equals 8 in there, that's 16, plus y equals 2, that's 18. So that actually checks out, doesn't it? So, so that's that. Now, in some situations when we're doing these, we may not find that there's a simple addition or subtraction. We might need to scale up either or both of these equations so that the coefficient of x or the coefficient of y is the same in both equations. So we could, for instance, multiply this first equation. We can multiply it by through by 3. That would give us 6x plus 3y equals 54. And then that might actually fit next to our second equation, or we might need to scale this one as well. But again, it's a little bit like, you know, your weighing scales. If they're in balance, if you double what's on the left-hand side and double what's on the right-hand side, you're still going to end up in balance. So that is that's how we do these simultaneous equations. These are linear simultaneous equations, incidentally. The other thing you might just to be aware of is that if you haven't seen this, that each of these two equations represents a line on a graph. And there is one point, of course, which is on both of those lines, and of course it's the point where those lines cross. So we could draw these and then find the point where they cross, and in fact that would be this point here. The coordinates 8 and 2. X equals 8 and y equals 2. So that's basically the graphical way of solving what we have just solved algebraically. Right. Okay, so that has worked through that paper, or at least a selection of the questions. I really hope that's been useful for you, and there are other examples of papers worked through that you could maybe refer to, give you a few ideas as to how these things should be done and how you might set things out clearly and neatly to help the examiner. Okay, all right, thanks for listening.